Hi everyone. We're experimenting with recording ACT review packet number 5, data and probability. The first four problems are the perform questions, and then comes the on your own problems. So let's start with number 19. Number 19 says, in a company of 50 people, there are 30 males, and they have an average age of 42, and there are 20 females that have an average age of 37. To the nearest year, what is the average age of the company's workforce? Well, in order to find the total average age, I need the sum of all the ages over the total number of people. And the way I'll get the sum of all the ages is I'll take the fact that there are 30 males with an average age of 42, and that there are 20 females with an average age of 37. And this will give me, up here in the top, will give me the total of all the ages. On the bottom, how many people do we have? We have 50. Well, if I pull up my calculator and evaluate this expression, I get 40. The average age of the workforce is 40. That's number 19. Okay, 20. For 20, we're told survey is conducted regarding a proposed change in the attendance policy by year, 1L, 2L, 3L, and whether they're for or against the policy. What fraction of all 1Ls and 2Ls? Okay, so they said fraction, and they said what population we're considering is all the 1Ls and 2Ls. And what is it that we're looking at? Who are against the policy. We want against. We want 1Ls who are against and 2Ls who are against. So to me, I see there are 16 1Ls against, 12 2Ls against. There are a total of 58 1Ls and 64 2Ls. So I end up with 28 over 122, which reduces to 14 over 61. That's letter G. G for number 20. Okay, 21. 21 says how many positive 4-digit integers. Okay, so I need 4 spaces for 4 digits. And have 3 as their hundredths digit. So I only have one choice for the hundredths digit. That's the number 3. I have one choice for that slot. And 5 or 9 in the ones digit. So this has to be a 5 or 9. So I have 2 choices for this spot. It says here, I'm looking for a 4-digit number. So I know this first number can't be 0. This number were 0, this first number were 0, I would have a 3-digit number. So instead, I know this can't be 0, which means the only numbers that work are 1, 2, 3, 4, 5, 6, 7, 8, 9, which means I have 9 choices for this. And how many choices do I have for the 10 slot? Well, that could be a 0, that could be a 1, that could be a 2, a 3, a 4, a 5, 6, 7, 8, and 9. So we've got 10 choices here. And this problem is an example of the counting principle, where we want to know how many different possible 4-digit numbers we can have with this. We multiply all these choices together. 9 times 1 is 9, times 10 is 90, times 2, and I get 180 choices. And that corresponds with A, choice A. Remember, this is the counting principle. I multiplied the number of options. Okay, and then problem 22. A fair coin is tossed. What's the probability of obtaining at least 2 heads when we toss the coin 3 times? Okay, so we'll toss the coin once. You can have heads or tails. You toss the coin a second time. We can have heads or tails. We can have heads or tails. Now we'll toss the coin a third time. We'll have a head or a tail, a head or a tail, a head or a tail, a head or a tail. And that's three coin tosses. We're looking for at least two heads. So here's 1, 2, 3 heads. This path works. Are there any others with 3 heads? I don't see any others with 3 heads, but I see some with 2 heads. Here's a path with 2 heads. That's at least 2 heads. And then I see another path with 2 heads. And then over here, if I threw tails first, I could then have heads. So it looks like there's a fourth choice. How many total paths are there? 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4 of them work for at least 2 heads. So that means at least 2 heads. The probability of at least 2 heads is 1 half. And that corresponds with H. Alright, let's take a look now at the on your own problems. On your own. Mary's goal is to collect 200 cans during the food drive. During the first 4 days, she averaged 10 cans a day. So day 1, she got 10 cans. And 2, she got 10. 3, she got 10 cans. 4, she got 10 cans. Maybe she had 11 here, and 9 here, and 12 here, and 8 here, but the average was 10 each day. Okay, so she's already got, by day 4, 40 cans. But remember, she was looking to pick up 200 cans. So how many more cans does she need? She needs 160 more cans. And we're told here, with the 10 remaining days. So how many cans does she need to get per day? Well, 160 cans. She has 10 days to do it. That'll reduce to an average of 16 cans per day. And that is choice C for number 1. Okay, let's look at number 2. Number 2 says a cooking class has 20 spaces available for each daily lesson. Data shows that 19 people attended the first session, 17 attended the second session, and 15 people attended each of the remaining sessions. Okay, so we had 19, and then we had 17, and then we had some number of 15. But when we divide it by the number of sessions, it tells me that the average was 16 people. Well, I'm pretty sure there's this really horribly hard way to do this problem, but the way I thought about doing it is our average is supposed to be 16. Well, let's examine these numbers. This first number is 3 above our average. And this second number is 1 above our average. So after the second day, we're 4 above average. Well, I notice that these 15s that follow are 1 below average. How many days with 15 do I need to overcome all those more than 16s to get back to an average of 16? If I'm 4 above, I think I need 4 days of 15 where I'll go 1 below each of those 4 days, so that I'll end up with 4 above plus 4 days of going 1 below the average to get to the average of 16. So 4 days of 15, 1 day of 17, 4 days of 15, 1 day of 17, and 1 day of 19 for a total of 6 days. But how many days with 15 did we have? We had 4 days with 15 to overcome those that were more than the average. So how many total sessions were there? There were a total of 6. That is choice H for number 2. Let's look at number 3. It says, Mr. Foster took students to a driver's education class, the Department of Motor Vehicles, took driver's license test. The number of questions missed by each student is recorded on the bar graph below. Which of the following statements must be true? More than half of the students missed 5 or more questions. Well, I noticed from the bar graph that 7 students missed 5, and 3 students missed 6, and 3 students missed 7, and 2 students missed 8. So that's a total of 15 students missed 5 or more. But I noticed when I count out all the number of people, we had 2 people get 1 wrong, and we had 3 people get 2 wrong, and we had 4 people get 3 wrong, and we had 5, 6 people, we jump up, 6 people got 4 wrong, and then our 7 people got 5 wrong, 3 people got 6 wrong, 3 people got 7 wrong, and 2 people got 8 wrong. Alright, so how many people are there total? Well, it looks to me like there are 2, 3, 4, 6, 7, 3, 3, 2 people total. That's 5, 9, 15, 25, 30 people total. So we said that 15 of those people missed 15 or more. And choice A says more than half of the students missed 5 or more questions. Well, that's exactly right. That's not more than half. So choice A, I don't think so. Let's take a look at choice B. Choice B says the mean number of questions missed was between 4 and 5. Okay, so if I'm thinking about the mean value, I want to think about this list that I just wrote. 2 times 1 plus 2 times 3 plus 3 times 4 plus 4 times 6 plus 5 times 7 plus 3 times 6 plus 3 times 7 plus 2 times 8. Now, what is this going to represent? This is going to represent the total number of missed questions. If we divide the total number of missed questions by the number of people, we can find out the mean. So what do we get on top? We have 2 plus 6 plus 12 plus 24 plus 35 plus 18 plus 21 plus 16. And I add those all together, and I end up with 134 over 30, which, 4 times 30 would be 120. And 5 times 30 would be 150. Is this number between an average of 4 and 5 missed problems? It sure is. So I'm going with choice B here. The mean number of questions missed was between 4 and 5. A total of 134 points divided amongst 30 people means a little more than 4 problems were missed per person, and that's certainly between 4 and 5. So my choice for number 3 is D. Let's move on to the next page, number 4. Number 4, water record. Okay, so we've got a line plot. I see 2 people were carrying half a liter, and one person carried 3/4 of a liter, and one person one, and one person had 1 1/4 liters, or 5/4 of a liter, and we had 3 people, oh no, 4 people with 1.5 liters, or 3/2 liters, one person with 2 liters, and 2 people with 2.5, 5/2 liters. So if I simplify this expression, I get 1 plus 3/4 plus 1 plus 5/4 plus 6 plus 2 plus 5. 3/4 plus 5/4 makes 8/4 for 2. 1 plus 2 plus 1 plus 6 plus 2 plus 5. That's going to be 4 plus 6 is 10, plus 7 is 17. So there are 17 total gallons that were brought. And how many campers were there? Well, how many marks were there? There were 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 campers. So if I divide the number of gallons amongst the number of campers, I get that each camper is carrying 17/12 gallons. And that seems to correspond with J. 1 and 5/12. Okay, so number 4 is J. Let's take a look at number 5 now. Jordan owns a small car dealership. He plans to display a number of different types of vehicles in a circle graph. Remember, a circle graph has 360 degrees. He's got 64 subcompact cars, more subcompacts than any other company. And that is 64 out of 320. 64 out of 320. Well, he wants to convert 64 out of 320 to some sort of representation in a circle graph, where the total on the circle graph is 360 degrees. And we want to know how many degrees this 64 out of 320 ratio would be. Well, I don't know. So I'm going to multiply both sides by 360. And I'll see that these cancel. I'll have x by itself on the right-hand side. There's some canceling I can do on the left. I can start by taking off these zeros, dividing top and bottom by 10. I also notice that 4 goes into 38 8 times, and 4 goes into 36 9 times. Ooh, look, and then this 8 can cancel with that 8. And so I'm left with 9 times 8, or 72 degrees, is how many degrees I should have on my circle chart. My circle chart starts with this proportion and solves like an Algebra 1 proportion problem to become x equals 72 degrees. 72 degrees corresponds with choice D for number 5. Number 6. The table below gives the frequency of grades at a certain interval for 25 test grades in an AP Stats class. Which interval contains the median? Well, I noticed when I looked at the frequency column that we had 5, 7, 7, 4, 2. So I started counting this way. I had 2, and then I had 6. Where does the 6 come from? It's the total of these two numbers. If I keep going up this way, I'm going to add 6 and 7 and get 13. Okay, so let's come back the other way. Now I've got 5. Now, if I go further, 5 and 7 is 12. Well, halfway between 25 would be 12 and a half. So it would be right in between these two. What choices were those? Well, that was 81 to 90, and that was 71 to 80. So Where is 12.5 going to be? 12.5 is within this 13. So this is my choice, choice HC, 71 to 80. Okay, number 7. Seven gives us a table, a probability distribution. If your computer program uses distribution randomly to generate the value of x, what is the probability that the value will be odd? Well, when we look at this x table, 0, 1, 2, 3, 4, I notice that there are only 2 odd numbers in it. And those 2 odd numbers are 1, that has a probability of 1/10, and 3, which has a probability of 3/20ths. So what's my probability? Well, I'm thinking about 1 over 10 plus 3 over 20. I need to make a common denominator here, 2 over 2. I get 2 over 20 plus 3 over 20. That'll be 5 over 20, which reduces to 1/4. So, what is the probability of odd? Probability of odd is 1 in 4, and that corresponds with choice D for problem number 7. Okay, number 8. I need to think a bit on number 8. Based on the probability distribution in that table up there, what's the expected value? Well, we've seen expected value before. It's that mean thing that we did where we multiplied the choice times how many of that choice we have, but that choice times the probability of the choice. So, for example, we have a choice of 0, and the probability is 1/5. And we have a choice of 1, and the probability is 1/10. And we have a choice of 2, and the probability is 3/10. And we have a choice of 3, and the probability is 3 over 20. And we have a choice of 4, and the probability is 1/4. Okay, so what do I have here? Well, the first term, 0 times stuff, that goes away. And then I'm looking here, and I'm noticing some canceling I can do. But I also think I should make a common denominator here. So I think I'm going to go with 20ths, 2 20ths plus, multiply here by 2 to get 20. This will be 4 times 3, 12 20ths. And now here we have 3 times 3, 4, 9 20ths. Plus, remember these 4's over here cancel, leaving me with 1, which would be the same as 20 20ths. So what are we looking at? 29, 31, 41, 43 20ths. Or 2 and 3 20ths. This is choice A. All I had to do was multiply the choice by its probability, add those all up, and that was my expected value. My expected value is 2 and 3 20ths. Okay. Number 9. Alicia is playing a game in which she draws marbles from her box. There are total 50 marbles, numbered 1 through 50. She draws one marble from the box and sets it aside. She draws another marble from the box. If both marbles have the same units digit, and at first she drew out the one numbered 25. Well, the units digit, if she took out 25, the units digit is 5. What other numbers between 1 and 50 have a units digit of 5? 5 does, and 15 does, and 35 does, and 45 does. So how many are there then? Well, it looks like there's 1, 2, 3, 4 other choices that she could have. Now, remember, she pulled this one out. So one of those 50 marbles is gone, which means she's only got 49 marbles left to choose from. But she's looking for one of four choices, 5, 15, 35, or 45. So she only has a 4 in 49 chance of pulling out another marble that has a 5 in the ones digit. And this corresponds with choice D for number 9. Number 10. License plates on a certain state contain 6 alphanumeric characters, the letters A through Z. There are 26 letters, and the numbers 0 through 9. There are 10 numbers. So this is a total of 36 choices. O, but wait, I and O can't be used, so I don't really have 26 here. I've only got 24 plus 10 numbers for a total of 34. How many choices do we have for our 6-character license plate? Well, this could be any of those 34. And they didn't say we couldn't repeat, like have 99999 as a license plate number. So I think I still got 34 choices for this one, and 34, and 34, and 34, and 34. So if I allow repeats, as this problem does, and using the counting principle we talked about before, I just have to multiply all these together, and that would be 34 to the 6th power. And 34 to the 6th corresponds with H. H is 34 to the 6th to number 10. Let's take a look at problem 11. Problem 11, what is the average of the expressions? Well, I'm going to add up all those three things and divide by 3 expressions. 2x plus 5 plus 5x minus 6 plus negative 4x plus 2. I want to add up those 3 expressions, and then I want to divide by 3 expressions. So I have 7x minus 4x is 3x. 5 minus 6 is negative 1, plus 2 is positive 1, divided by 3. And if I break this into 2 fractions, my answer is x plus 1/3. X plus 1/3 corresponds with choice C. C for number 11. Remember, in the spring, having a practice ACT test that counts as a test grade in our class. So hold on to these reviews when you get them back graded and study them for that test. Brooks scored an average of 30 points per game. This is problem number 12. The number of points he scored in each game below. How many did he score in game 6? Well, it told us that he had an average of 30 points per game. And we know that that average was made up of the total of all the points from all the games, 28 plus 31 plus 20 plus 42 plus 32 plus how many points did he get in the 6th game? Well, I don't know, but I know I'm supposed to take the total of all those points, divide by 6, and the result will be 30. Now, I can tidy up the top here, and I get 153. So 30 equals 153 plus question mark over 6. Well, let's solve this equation for a question mark. Start by multiplying both sides by 6. That'll give us 180 equals 153 plus question mark. Why? Because these 6 is 10. And so then I'm just going to subtract 153 from both sides. And I'll get question mark for how many points in game 6? 27. 27 points in game 6 corresponds with choice G. G for number 12. Okay, let's take a look at 13. We're about halfway done with the packet. 13. The table below shows his income from 1989 to 94, Which years from 90 to 94 show the greatest percent increase over the previous year? Okay, so percent increase is a formula that I remember learning when I took Algebra 1. It's new minus old over old. So if I want to find the percent increase for 1990 over 1989, I would do 25,000 minus 20,000 over 1990 minus 1989. That would give me 5,000. Oh, sorry. Not what I was doing. I'm supposed to be doing new minus old over old, not the slope formula. Remember, we're looking for that old number, that 20,000. That's what we want on the bottom. So we still have 5,000 on top, but on the bottom we have 20,000, and so that turns out to be 1 over 4, or 0.25. Well, if I repeat this over and over, I'm going to get for the next one 30,000 minus 25,000 over 25,000. That's going to be 5,000, but this time over 25,000, which ends up being 1 over 5, or 0.20. This percent increase is smaller than our first percent increase. I'm interested in the greatest percent increase over the previous year. And when you go through and compute all of the percent increases like I did, I got that this was the highest percent increase. Let's take a look at the last ordered pair, 44,000 minus 36,000 over 36,000. Many students choose this last option as the greatest because the difference on top is greatest at 8,000. But if I do 8,000 over 36, that was a little extra zero there, over 36,000, not 80,000, but 8,000 over 36, I end up here with 2 over 9. Well, 2 over 9 is, let's do it, 20 divided by 9, that goes in 0.2 for 18, which is 2, I bring down another 0, I get a 2, that's 22%. Well, my first one was 25% increase. So even though this has the biggest jump at $8,000, my first year's change from 20,000 to 25,000 yielded the greatest percent change, 25%. And so what year did this happen? This was 1990. And so I'm going with choice A for problem number 13. Okay, problem 14. Let's take a look. Problem 14 says, what percent of participants experience severe side effects? Read carefully. It's not just F that has severe side effects, but also C has severe side effects. So F was 27.75%. C was 6.5%. And when we add these together, we get 5, 2, carry the 1, 4, 34.25% at severe. So when I look, I notice that that corresponds with choice J for number 14. But wait, we're not done with this table yet. We use this chart for problems 14, 15, and 16. So let's move on to number 15. how many more participants experienced mild or no side effects than severe side effects? Well, let's count up all the mild or no side effects. It looks like that's Group A and Group D. Group A had 34.25%. Group D had 9.5%, or a total of 43.75%. Remember, these are people who had mild or no side effects. And the question doesn't ask us how many people had mild or no side effects. The question asks us how many more people experienced mild or no side effects. So I'm going to have to subtract the 34.25% of people who did have severe side effects, and that will give me 9.5%. And how many people were in the study? 400 people. So if I do 0.095 times the 400 people in the study, I end up with 38 people more had mild or no side effects compared to people with severe side effects. Okay, and then problem number 16, what percentage of participants who experienced severe were given the drug? Well, we said before in problem number 14 that 34.25 experienced severe. But what portion of those people were given the drug? Well, when I read through the choices A through C again, notice severe side effects drug is choice F, and F is 27.75. So that's with drug severe. If I divide the top by the bottom, I end up with 81%, which is choice J. Choice J for number 16. Let's take a look at problem 17 now. At a district-wide student government convention, one female, one male was selected to lead discussion. If there are 90 females and 125 males, Doja would like to have a word. One moment, please. Here we go, number 17. So we need to send how many different two-person combinations of one female, one male are possible? Well, the number of females was 90, and I wanted to choose one. And the number of males was 125, and I wanted to choose one. Well, I am not one to use the combination formula by hand, so I would put out my calculator and do and choose R under math, probability, and I believe it's choice 4 is N choose R. Now notice with N choose R, you have to plug in the N value, then you have to go to N choose R, then you plug in the R value. So in my calculator, I would be typing 90, then I would do math, probability, number 4, and that would give me C, and then I would type in 1. And this turns out to be 90. And in fact, why bother with the calculator when we know that this is going to be 125? Well, the answer is that I'm taking a combination of 90 choose 1 and multiplying it by a combination of 125 choose 1. So that's 90 times 125 for a total of 11,250, which is choice E for number 17. Number 18. Which of the following expressions gives the distinct number of permutations of letters in statistics? Well, statistics is a 10-letter word, and so we could have 10 for the first letter, 10 choice of... Never mind, I take that back. We've got a 10-letter word, and so we know that's 10 factorial. But we need to divide out our duplicates. For example, how many t's are there? There's 3 t's, so we're going to divide by 3 factorial. How many s's are there? Ooh, there's 3 s's, so we're going to divide by 3 factorial. How many i's are there? There's 2 i's, so we have to divide by 2 factorial. Now remember when you went to math, number, and you saw, math, probability, and you saw n choose r as number 4? Well, number 1 is factorial. So I can go to my calculator and ask my calculator for factorial. You could write this out as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial, which is 3 times 2 times 1, times another 3 factorial, 3 times 2 times 1, times a 2 factorial, 2 times 1. So what can we cancel? Well, this 6 will cancel this 6, and this 2 could take out this 2, and this 3 could take out this 3, and this 2 could take out a 2 from here, and I'd be left with 10 times 90 times 56, or 900 times 56, which turns out to be, oh wait, I didn't even need to do that. Look at the choices. Choice K, 10 factorial over 3 factorial, 3 factorial, 2 factorial, and we were all done back then. Okay, let's take a look at number 19. Number 19 says, 2 marbles are randomly chosen from a bag that contains 3 red, 2 blue, and 7 green. That's a total of 12 marbles. Okay, what is the probability of picking 2 green marbles? 2 green marbles. Well, let's see. I'm thinking about picking 2 green marbles. How many greens are there? There's 7. So that's a combination of 7, choose 2. And how many marbles did we want to choose? We wanted to choose 2 from our pile of 12. I would definitely do this on the calculator. When I did 7 choose 2, I got 21. And when I did 12 choose 2, I got 66. And this would reduce down to 7 over 22, or choice A. Again, I'm using combinations from math, probability, C, N, C, R. Remember, you have to type that first number first before you go to the math button. You gotta type that 7, then go to the math button, go to probability, choose NCR, and then type in the 2. Okay. So there we go with choice A for number 19. Number 20. High school is raffling off college scholarship. A girl has a 55% chance of winning, and there are 154 juniors who are girls. Well, I know that 154, not 155, 154 girls represents 55% of times the total population. X equals total population. So if we divide both sides by 0.55, I get that X equals 280 total students. Well, we said that 154 of these total students were girls. So how many boys do we have? I get 126 boys. And that's choice G. G for number 20. Okay? 21. We can do 21 one of 2 ways. They ask us for the probability of completing at least 1 pass. That means the probability of 1 pass plus the probability of 2 plus the probability of 3, oh, isn't it? Plus the probability of 4, plus the probability of 5. We could add up all those probabilities, and we would get the probability of completing at least one pass. Or we could say 100% minus the probability of completing no passes. This is a lot less work. So I did 1 minus 0.0219 and came up with 0.9781. This is the probability of completing at least one pass. So we can add up all 5 of these choices to get this number, or we could do 100% minus not being successful. These 5 were being successful, at least one completed pass, or 100% minus no completed passes. Both of these give us the same answer, choice E for number 21. Okay, number 22. We've got lots of birds. Buntings, meadow, there were larks, and sparrows. Now we know that the buntings was 35 over 176, and we know that larks, this is buntings, we know that larks was 5 to 11. I'd really like to be able to compare these numbers, but unless I have a common denominator, I can't do that. Hey, does 11 go into 176? It sure does, 16 times. So I'm going to multiply top and bottom by 16. So I can see 35 out of 176 birds were buntings, 80 out of 176 birds were larks, and so what does that leave us for sparrows? Well, we have a total of 176 birds, and we've already accounted for 35 plus 80, or 115. No, we've accounted for 115. We want 176 minus 115, which is 61. 61 of these 176 birds could be sparrows. Which was the greatest population? Well, it looks like 80 out of 176 larks. And that's why I chose G. G for larks. Okay, I certainly do like G in this packet. I had to determine the number of sparrows to figure out if larks, which already seemed like a big number, was in fact the largest. All right. 23. Jamal had a suitcase that contains 10 white socks. He wants to add enough black socks so the probability of randomly selecting a white sock is 1 in 5. Well, he's got 10 white ones. So I need this number on top to be 10. What would the number on the bottom have to be? Well, if I multiply the top by 10, I need to multiply the bottom by 10, and that would give me a total of 50. If 10 of them are white, how many have to be black socks? Well, 50 socks minus 10 white ones gives me 40 black socks. Jamal must like black socks. C is the choice for number 23. Okay, 24. Histogram shows car rental agency is available for rent by fuel efficiency. What is the probability that the car will have a fuel efficiency rating of at least 25 miles per gallon? Well, the third column says 20 vehicles have between 25 and 30, and 6 vehicles have between 30 and 35. So that's a total of 26 out of how many total vehicles were there? Let's see, there were 8 in the first column, and 16 in the second column, and 20 in the third column, and 6 in the fourth column. So we had 26, and 6 is 32, 42, a total of 50. So 26 out of our 50 cars have fuel efficiency standards of at least 25 miles per gallon. This reduces to 13 over 25, which is choice H. Choice H. finally, the last problem we're going to do in this packet, number 25. We've got the baseball stadium has 12,000 seats. We've got probability. Oh, this is another expected value problem. 0.4 times the probability plus 0.5 times its probability plus 0.6 times its probability plus 0.7 times its probability plus 0.8 times its probability, and I end up with 0.58 when I do all that computation. Now, it's 58% of what? 58% of those 12,000 seats. 120, but 12,000 seats. And that turns out to be 6,960. Remember, when you add up all of this, you'll end up with 0.58. You're not done then. You still need to multiply that 58% by the total number of stadium seats. So 58% of 12,000 gave me 6,960 seats, or choice C. There ended AACT review packet number 5, data and probability. I hope this was helpful.